Students, see one point. If y equals to f of x is even, then we know that f of minus x equals to f of x. From this we can write one condition that implies f of minus x minus f of x equals to 0. So this also you can take a condition for a function to be even or reverse. F of x minus f of x equals to 0. Sometimes what happens while doing calculations, straight away it may not be possible to show f of minus x equals to f of x, but by subtracting both the results we may get result as 0. Like this also we can check whether the function is even or not. Next we will study about odd functions. A function y equals to f of x is odd if f of minus x equals to minus of f of x. That means by replacing x in the original function, if it is equals to the negative of the function, then the function is said to be odd. That's why if f of x is said to be odd, only if f of minus x equals to minus f of x. For example, we can take f of x equals to x cube. So standard graphs I am taking. F of minus x equals to minus x whole cube. So which is minus x cube, that is minus f of x. Therefore, f of x is odd. Like that trigonometry wise, if you observe, see, f of x equals to sin x we will take. Then f of minus x is sin of minus x. We know that sin of minus theta is minus sin theta, that is equals to minus f of x. Therefore, f of x is odd. Like that we can check whether a function is odd or not. And one more case from this here itself I am writing, we can take this also. This is also a condition for odd. Since f of x equals to, f of minus x equals to negative of this, if we bring here, that means f of x plus f of minus x both gives 0. Now here we will observe the graphical nature of odd function. See, x cube graph is a standard polynomial. We know that it appears like this type, it passes through origin. Next, sine function. So on this side it will be like this type, and on the other side it will be like this type. Okay. So now both the graphs, if you observe, see, about the origin. So here whatever is there, its reflection is there, and here this is the sine wave and its reflection here. See. So now here both the graphs, if you observe, they are symmetric about origin, not about any axis. They are symmetric about origin. So here it is going, and if you treat origin as mirror, then whatever is there, its projection is appearing here. See, its mirror image is coming, and this is this one, and its mirror image is this one. So that means odd functions, if f of x is an odd function, then it is symmetric about origin. So two things we studied: even functions are symmetric about y-axis, and odd functions are symmetric about origin. Okay students, here the point to remember is, see, it is not necessary that every function should be either even or odd. There exist functions which are neither even nor odd also. For example, if we take some more standard function, that is log x to the base c. So logarithmic function, if we take, we will try to check f of minus x. F of minus x means we will get logarithm of minus x to the base c. That's it, it cannot be simplified further. So here we won't get any condition like f of minus x equals to negative of f of x or same function. Then we will say that f of x is neither even nor odd. So N-E-N-O, that is nano, neither even nor odd. The first question I am taking, f of x equals to 2 to the power of x minus 1 by 2 to the power of x plus 1. Now we will check whether it is even function or odd function. Always the immediate basic is replace x with minus x. Then we'll get f of minus x equals to 2 to the power of minus x minus 1 by 2 to the power of minus x plus 1. Here simplification possibility is there. We can write it as 1 by 2 to the power of x minus 1 by 1 by 2 to the power of x plus 1. So that means what we'll get 1 minus 2 to the power of x divided by 1 plus 2 to the power of x. Now from the numerator we can take minus common. 2 to the power of x minus 1 by 2 to the power of x plus 1. So this is f of x only. So that means what we are getting minus f of x. So we notice that f of minus x is equals to minus f of x. Then we can declare this function as odd function. Next question is f of x equals to logarithm of x plus under root x square plus 1 to the base e. You people check this one, sir. Students, what type it is? What type of function? Neither even nor odd. Still anyone? Okay, students, check this one. We'll take f of minus x. That is logarithm of minus x plus under root x square plus 1 to the base e. Structures are somewhat similar type appearing, and here structure is a plus b and here a minus b. Then we need to think like this: f of x plus f of minus x will take c. That means logarithm of x plus root of x square plus 1 plus logarithm of minus x plus root of x square plus 1. Now this is appearing like log a plus log b is log ab. That is equals to logarithm of ab. The product of these two, if we take minus x into x is minus x square, and product of those two is we will get x square plus 1. So x square cancel, then what will get log 1 to the base e, that is equals to 0. F of x plus f of minus x equals to 0, therefore f of x is odd function. I'll write here, say f of x equals to logarithm of x minus 1 by x plus 1 to the base e. Immediately we will check f of minus x. That is, what will get logarithm of minus x minus 1 by minus x plus 1. This is what good. Logarithm of minus common means we will get x plus 1 divided by minus common here means we will get x minus 1. So after taking minus common, these two we can eliminate. Then we are getting here logarithm of x plus 1 by x minus 1. I want to write this one as x minus 1 by x plus 1 whole to the power of minus 1. The same thing only. So now we will get this minus, if we bring here, we will get minus logarithm of x minus 1 by x plus 1. So this is your f of x. So that means we can write it as minus f of x. Now f of minus x equals to minus f of x. Therefore the function is odd.